Well, dear friend, in last video I have proved that intensity I equal to K bracket A1 square plus A2 square plus 2A1 A2 2A1 A2 cos phi. Phi is the phase difference between two waves. Now what happens if A1 A2 same? If here A1 equal to A2 equal to A. Now how this formula get modified? K bracket A square plus A square plus 2A square cos phi. K 2A square plus 2A square cos phi. Or it is 2Ka square 1 plus cos phi. There is one formula cos 2A. Yeah, cos 2A is equal to 2 cos square A minus 1. And hence cos A again 2 cos square A by 2. So 1 plus cos A is equal to 2 cos square A by 2. So if I use this here in this form, so we get I equal to 2Ka square bracket 2 cos square phi by 2. Or I equal to I equal to 4Ka square cos square phi by 2. And then need to have large value of maximum amplitudes of two sound waves are taken equal. To have a good contrast between loud and low sound, the amplitude of two waves should be equal. Many questions are asked on this formula in competitive exam, and students think from where this formula has come. Now, I will tell you how the intensity varies with place. Suppose there are two sources of sound, S1 and S2, emitting sound wave in same phase and same frequency. We can have easily two sources of sound emitting sound in same phase and same frequency. Here, this is a line joining the two. This is right bisector of this line. So point O lies on right bisector. यानी कि M is the midpoint here. And then we may take any point P. So suppose S1 and S2 are two sources of sound emitting sound of same frequency in same phase. And OP is the plane of observation. You are an observer moving along this line. Then how will you find the intensity of sound? यहाँ पर आपको कैसे मिलेगा? Point S1O, this wave will go this way. So since point O lies on right bisector, since O lies on right bisector, of line joining S1 and S2. So S1O equal to S2O. Why I'm writing like this? We know delta phi equal to 2 pi upon lambda into delta x, where delta phi is the phase difference between two particles when path difference delta lambda. Here sound waves start in same phase, meet at O with delta x 0. At O, delta x 0. So delta phi 0. When phase difference 0, they meet same phase, so we get maximum sound, not only on point A. Wherever you come on this point line, or along this line, you will be getting maximum intensity. Because S1, S2 are in same phase. If S1, S2 are in opposite phase, the sound from S1, S2, then along this line you don't get sound. If A1 is equal to A2. Now if we take point P, so here path S2P longer than S1, point will be this side also. So if point P, if there is a point P, if there is a point P such that S2P minus S1P plus minus n lambda, माइनस का वो जब P यहाँ होगा तो ये S2P छोटा हो जाएगा, where n equal to 0, 1, 2, 3, 4, so on. Then delta phi will be 2 pi upon lambda into delta x plus minus n pi, n lambda. So it will be minus plus 2n pi. Phase difference of 2n pi, if we multiply in same phase. So at every such point P, where the wave from sound wave from S1, S2 meet with path difference n lambda, we will get maximum sound. But if point P such that, so at every point P where the two waves meet in with path difference n lambda, we get maximum. तो यहाँ मान लो मैक्सिमम, फिर ये लैम्बडा हो गया, ये 2 lambda, 3 lambda, 4 lambda. So at these points you will get maximum. Now what will happen between this and this? ये maximum के यहाँ जीरो minimum भी आओगी, और intensity will be varying with distance. Now if P is such that S2P minus S1P equal to 2n minus 1 lambda by 2 plus minus, then delta phi will be 2n minus 1 pi. क्योंकि हमारा delta phi equal to 2 pi upon lambda into delta x. This relation I derived while telling about progressive wave. So delta x रखने यहाँ, we will get this odd multiple of pi means opposite phase. hence intensity minimum. Hence intensity will be minimum. And if A1 into amplitude of these two are equal, then zero intensity, no sound will be heard. Now you might be thinking where it happens. In our life, it is very common, we observe, but we people don't think. Actually, when I ask students some questions which we are using the phenomena we are using daily, then students say, sir, we have never thought like this. If you are a student of science and you are studying physics, then what is happening around you, you should try to understand how it is taking place. In a big hall, like cinema hall or any auditorium, you might have seen that false ceiling is used, curtains are used on the doors and windows. Why it is so? And you might have also observed in your house when a room is made totally vacant, no apparatus, no bed, no chair, no book is placed, then you find echoes of sound in the room. Because when you speak, the sound reflected goes to the different walls, get reflected, and it takes time to reach. So continuous sound is observed because from different corner and different walls and different floors, you get sound at different place, different time. And if anyhow, suppose the source, here you are observer here, it is a ceiling. So sound will directly come to you and may come after reflection like this. If the part difference between frequencies the same hai, if the part difference is such that it fulfill the condition of maximum, then you will get sound. If part difference become odd multiple by, you will get no sound. You keep on increase the volume of the device producing sound. In sea, ships travel and there are lighthouses which produce sound and give message to the ships to tell their position. This is lighthouse. Ship is here. It will get sound directly and after reflection from sea water. Actually, in reflection, I will tell you there occur phase change of pi radian. So condition gets changed. If this is odd multiple of lambda by 2, you will get maximum sound. Because this wave and this wave become in opposite phase because of reflection from water surface. Now when it moves further, it may not get sound because part difference has changed and the sound wave from this lighthouse meet in a good phase and minimum no sounder. When it moves further, he may get sound. So that way region of loud and low sounds are observed. In lab you have a device called tuning fork. Tuning fork device like this. These steel, made up of steel generally. These are called fork. This is one fork, this is one fork. This is the stem, hatta, handle, stem. When we strike the tuning fork on rubber pad, you can strike any, but we strike gently on rubber pad, then it vibrates and produce sound. Frequencies are given, you can see that in the lab. tuning fork. If you take tuning fork and vibrate here and keep it close to your ear and rotate like this. If you keep on rotating, you sometime you will get sound, sometime you will not get. Because two fork become two sources of sound of same frequency. Like this, when this line here equidistant, so they produce maximum. When it become like this, then they start oscillating in opposite direction, so you get no sound. So this is due to interference of sound waves. Actually, I have explained you interference here, though it is not in syllabus. It is like that in class 9 initially, early time, logarithm was taught in class 9. Now that has been deleted, so physics teacher has to explain the law. So we have to learn so many things from our own side. तो इंटरफेरेंस समझने के बाद आपको समझ में आएगा अगले टॉपिक बीट्स एंड अदर टॉपिक्स. So please don't think that it is beyond syllabus, but try to understand mathematics of superposition of waves. Beats and standing wave are again the phenomena which are produced due to superposition of two waves. Now you have got my point. Actually, y1, y2 are the displacement. So phase means direction. If two forces acting in the same direction like this, then the resultant will be this plus this to get added, become large. But if there is one is this, other this way, then the resultant will be, there may be this much only. So I hope you will watch the video. We are decreasing day by day. I don't know though exams, if every exam is coming closer to you. Please watch the video, like the video, share the video, and ask your friend to subscribe the video channel. If you have not subscribed, please you also subscribe the channel. Thank you.